Okay.
Recorded?
Yeah.
Okay, so we're loading the balls here, and then we will energize the stepper motor. Now it's energized, like so. Energize. Okay, now it won't go backwards. All right, I'll reset it here, and then we run the program. When we run the program, this stepper motor is gonna tilt, and while it's tilting, the IR sensor on here is gonna look for the IR LED on the target. Right? And as soon as the sensor finds the LED, it's gonna stop the tilt. Yeah. So we'll run that. So now it's tilting, and then yeah, and then so at this point the LED has been found, and the time of flight. Yeah, and the time of flight sensor will calculate the distance to the target. This is the time of flight sensor, and from that, it's gonna tell the motors to spin at a specific RPM, so that it's gonna shoot from here to the target. It's gonna do the velocity calculations and the RPM calculations itself. And on the back, we have a Scotch yoke mechanism.
Yeah, so the point of the Scotch yoke mechanism is that we left the border here so to stop the balls. When we start the program for the Scotch yoke, it pushes it up, and this is by pressing down on GP22 down here. When I press it, it's gonna feed the ball upwards into the flywheel.
There it goes.
And to control the speed of the motor, the flywheels, we have a motor control that sends motor driver board that sends a PWM signal to the, which is right here, which sends the signal to the DC 24 volt motors. And we also have a stepper motor that's controlled by this motor step driver. We learned that initially we had used a similar motor driver to control the stepper motor, but it was not enough current to control the stepper motor, so we had to upgrade to this. Okay, so what I learned from this project, a variety of things. Mainly, what I'm really interested was like the CAD portion and the coding. Coding was like a new thing for me. I coded a little bit of the feeding mechanism with the hobby servo that we used in our lab for 106, and it spins in the 360 motion over and over again to feed the balls in between the flywheels.
Okay.
Hi, my name is David Lopez. I did a lot of work on the SolidWorks design part of the model, including the flywheels and the sliding mechanism and the cup holders for the DC motors. And that's kind of what I learned through this project is that I want my main focus to be mechanical design. I struggle a lot with the coding, but I figured out with the Scotch yoke mechanism and all the SolidWorks modeling that this is kind of what I want my focus to be when I go into industry.
Ready?
Introduce yourself.
Hi, so my name is Zubin. I learned a lot with this project, especially the part which I worked on, which was coding these DC motors to run at the same speed. Initially, I was concerned that I would have to figure out a way to understand, okay, how can I, use sensors to check these RPMs and write some slightly complicated code to keep matching it and modifying the RPM. But there was a simpler way in which you use a tachometer and just measured it manually and basically found a linear relationship between the duty cycle you set it to and the RPM that you get, and you could graph and get an equation, and that was really cool because now I know for the future you don't always have to do something super complicated sometimes there's like a simpler solution. And also like the IR circuit, I worked on that with Andrew. We learned a lot about like how to like test circuits in an oscilloscope, just how to like modify the oscilloscope too so you get a correct reading, because that was definitely a big issue that we were having. And just yeah, and also like understanding how like driver boards, how they're important too, like how you need to have the right one that can take the right amount of current and voltage to be able to power the motors at similar speed. So
Yep.
that was all. Thank you.
Motor, we originally used the driver board that we used in lab, which was a red small board, but that one can only handle about 1.5 amps of current. But the mechanism has a lot of torque, so the stepper motor couldn't handle that much torque with only 1.5 current. So we moved to a bigger stepper motor driver, which is this one. This one can handle up to like 4.5 amps, which is good. So right now, if we power this on, it's much more stable compared to the red motor board. And yeah, the troubleshooting of the IR circuit took a really long time. From this, I learned like what each of the components are doing, like the capacitors and the resistors, and also the diodes. And we spent a lot of time on it, and we learned a lot from that. Yeah, that's about it.